Thank you for joining this session on giving feedback to students. So let's talk about this activity that you did. So if you could go back to slide 2, I want to take a look at this one. And what did you guys notice as you were completing this on slide 2?
It gave feedback, obviously, if you got it wrong, but then also if you didn't do the order of operations correctly, it specified that was what was wrong with it.
Yeah, that is what happened. So if you notice right now, there's a message that's there that says you have not entered anything. And when I go into the coding, I'll kind of talk about why I did that. But yeah, so I know if I gave this kid a problem, they might do 1 + 2 is 3. 3 times 3 is 9, and they did the order of operations incorrectly. And I know that's a misconception they're going to have. So I want to give a message to try to get them to think about, okay, well, what should I have done? If they got the right answer, which was 7, it would say great job. And the reason why I went in and did this one is because when giving explicit feedback to students, we have to be super careful of just giving a check or just giving an X, because if a kid put in 9 and it said it was wrong, they might not have any idea. But to try to give them some sort of hint based on some of the things that we know they would do wrong kind of helps us help them. I mean, of course, there's always going to be times where a kid might enter 10 for some reason unknown to me, so I can't give a specific message. I can just tell them that they're wrong. So how I did this is, so this was created, I have a note that gives the directions, and then I have this table where I've given 3 columns. And one thing also to be careful of when you're giving feedback in a table is automatically tables are set up to appear as math type, but since the feedback is something that I want to be used using regular text, I hit this drop down. Right now it says format as math, and that's what it is automatically. So I want to go here and I want to say format as text. That way when the message appears to students, it actually looks like regular text and it doesn't look like math type. So when working with a table and using answers and feedback this way, we want to label our table. So this is table 1. And so the coding that we're about to look at, each cell has a specific way that it's denoted. So the headings up here don't really count as a cell that students are going to enter in. It starts with underneath the headings. So this is the first cell, and the way this will be talked about is this is coming from row 1, column 1. So this is cell 1-1. This cell right here is row 1, column 2. So this would be cell 1-2. And then this is row 1, column 3. So this is cell 1-3. And I've explained that here. So this is an example of all of the information is grayed out because I put this little hashtag symbol in front of everything, and that makes Desmos not read the coding. When I want Desmos to read the coding, I would just get rid of this little hashtag. But again, this is just here to be informational for you. So the first thing that I'm going to talk about is something that we don't necessarily need to do in this example because there's only one cell that students will be typing in, but I want to preface it now because the next slide is when it's going to become important. So what I know is I'm going to give feedback in cell 1-3, but students will be entering an answer in cell 1-2. So I'm going to define that cell, which is right here, but I'm going to go ahead and type it so you can see what happens. So I'm just going to say A equals table 1 because that's the table that it's on, and then they're going to be typing in a numerical answer. So I'm going to enter cell numeric value, and again the cell that they're putting it in is row 1, column 2. So this right here is talking about students entering their answer in row 1, column 2. All right, now, based on the answer that they put in here, I'm going to give them a different message. And since it's a message that I'm giving them, I'm not giving them a numerical value, I'm giving them intent because I'm saying, hey, this is what you did wrong, or I'm saying, hey, this is correct, or I'm saying, hey, you actually didn't enter anything yet. So this would be cell content 1-3. Because in row 1, column 3, I'm giving them content. I'm giving them a message. So now I need to start thinking about, okay, well, what are all of the possibilities? All right, so we said students could be right. And so right here, students could be right. And I know the right answer is A equals 7. So when A equals 7, because again, A was defining the cell where they put their answer. So when A equals 7, I'm going to tell you great job. So if you right click, you can get an emoji, and there are all these different emojis you can pick from. So you can do whatever you want. I'm just going to go ahead and give a thumbs up. And I'm going to say great job. And you need to make sure you have quotation marks at the beginning and the end. And if you notice there's a warning symbol, that warning symbol is going to stay there until we're completely done, because what this says is there's a syntax error, quote, otherwise isn't there, because anytime we do something with content, whether it's in this feedback, whether it's in a note, you have a bunch of when statements, you always have to end with otherwise. And I'll talk about that when we get there. Okay, so first possibility is they could have been correct. They're correct when A equals 7, so I'm going to say great job. All right, another possibility is students are going to enter a wrong answer for a reason that we know. So like you said, the reason that we know was when A equals 9, I know they did that by incorrectly doing the order of operations. So again, I just chose a random emoji because I feel like maybe they'll be more likely to read it when there's a picture. I could say, I could be even more specific if I wanted to. I could say you added first, but that is not correct when following order of operations. So you can say anything you want. You can be more leading, you can be less leading, it's really up to you. All right, now there's also the possibility of they haven't actually entered anything, which is the message that you saw when you first started this activity. And they haven't entered anything because the cell is blank. So I'm going to say when is blank, and I'm going to talk about what it is that's blank. Well, what's blank is in table 1, my cell numeric value. So in table 1, my cell 1, 2 is blank. So what I'm going to say is, I'm going to put another emoji in there. I'm going to say you have not entered an answer. All right, so before I said anytime you have when statements, you have to end with otherwise, because there's always going to be this other scenario that we're not aware of. So I know that if they typed in A equals 7, I'm going to say great job. I know I'm going to say when A equals 9, this is what you did wrong. I know that when it's blank, I want there to be a message about it being blank, but they could type in some other random answer that I have no idea how they got it. So I'm going to say otherwise, because that's going to account for every other scenario. I'm going to say otherwise. Your calculations are incorrect. I still have a warning symbol, so let's see why. I think this actually has to be cell content. It does. I don't know why. Sometimes that happens. So that's best I can do right now. So now when I go in there and I preview it, nothing has been entered. You have not entered an answer. 7, great job. 9, you did the wrong thing. I put in some random number. Your calculations are incorrect. Okay, so that was a lot. Are there questions about everything that just happened in here, or anything that just happened in here?
So will this strategy only work when the thing they're going to enter in the cell is like a single number?
Yes, so it does have to be a numeric value. There are workarounds for doing something with text, but I think I want to save that for another time, just because there's a little bit more involved with that.
Yeah. Okay. So it can't be like an inequality or something with an infinity or anything like that. It's got to be like a numeric value. Just for now, anyway.
Yeah, for now. There probably is a way. I haven't actually tried it yet with infinity, So I can't speak to that. I don't want to tell you something that's wrong. But if we're talking about an inequality, what happens on the next slide might be a workaround for that. So I'll go through the next slide and that might kind of get your mind going. Because again, I haven't entered those specific types of answers, so I can't say yes or no to that.
Okay.
Are there any other questions about anything on this slide? All right, if that's the case, let's go to the next one because this takes it a step farther. So do you remember what happened? Oh, that's not the right version. Let me go here. So on this one, is there anything that you noticed when you started putting in answers? If you didn't notice anything, that's fine, but I'm going to point out specific things, and I just want to see if anyone noticed it.
For the fraction division, I think that's the one I put a decimal in and it took it.
Okay, so it took a decimal answer, even though you would assume or hope that a kid would type in a fraction.
Right.
Okay, good. That was something I hope you would notice because that's what I want to talk about. And that kind of goes along with the first one also. So let me go ahead and start kind of going through what happened here. So yes, on that note, like on this one, so I know the answer is 4/3 because I just remember doing this at this point. And if you notice, when you put something in a table, if you put it in as a fraction, it automatically is going to convert it to a decimal, and we can't do anything to stop that. So maybe this would, depending on the reason why you're giving feedback on kids' answers, sometimes the table is not the best way to do it. Sometimes it is, it really just kind of depends on what your intentions are. So just kind of as a side note, for example, let's say I'm doing geometry and I want kids to do multiple things in one problem. Maybe I want them to find X, then I want them to find 3 missing angles. I might choose to use a table because I could have uploaded an image that they have to work from, and they could have entered all of their answers that comes from the same problem. So that might be why I decided to use a table. But again, it really just kind of depends on what you're comfortable with. Then on this one, the answer is the square root of 10, but again, it's going to take it and turn it into a decimal, and I can't stop that. So on this problem, if students were to work this out and not simplify it, they would do 1/2 times 4/3, and they would end up getting 4/6. And if you notice, it says great job. So I will preface this with, there is a way to get it to check for a simplified fraction, but it takes what we're doing now and adds a whole nother layer of coding. And I feel like we're not ready for that yet. Like I want to get your feet wet with just like making sure you can do how to do multiple rows in coding, but we will get to a point where I can show you how to get it to check for a fraction. Right now, I just don't think that that is going to be a simple thing. Okay, so now on slide number 7, the background of it, again, I have a table and I have a note. I'm sorry, I have a note and then a table. This one I've designated as table 2. And now I have 3 places where students are going to enter an answer. So this is going to be cell 1-2, this is going to be cell 2-2, and this is going to be cell 3-2. And then I'm giving them feedback again in the 3rd column. So let's look at the coding behind this. This time I'm not going to type all of it because it's all there and I typed it on the one before. So again, we have 3 places where students are going to enter an answer. So I can't just say A equals every time because I need different variables to represent each cell. So I'm going to say A1 is equal to the cell, the first cell, so the one in row 1, column 2 in my table. I'm going to say A2 is going to be the answer that they put in row 2, column 2. And then I'm going to say A3 is what students enter in row 3, column 2. So this is the column where they're putting their 3 answers. What I know is going to happen is that students are going to get feedback in the 3rd column. So I want to make sure that I designate what's happening in each row. So in the first row, they are going to be given a message in row 1, column 3. So this is where I want to, again, talk about what you need to do, because we're not typing an actual fraction here, but the answer is 4/3. And I know that 4/3 is equal to 1.3 repeating. So I'm going to say that the acceptable answer is between 1.3 and 1.4. So I'm no longer going to say like I did last time where I said when A equals this, this is correct, or when A equals this, this is wrong. Now I want to give a range. So I know that the correct answer is when my answer was 1.3 repeating. So when A is greater than 1.3 and A1 is less than 1.4, this gives me my range. So anything that's typed in between these two, so if they were to enter 4/3, they'll get it correct. But if they type in 1.33333, they're also going to get it correct. So I'm going to say great job. They might have done it incorrectly and gotten 2/3 by doing some crazy stuff. So they could have gotten 2/3 by distributing the fraction to the 5, but not to the 1. So if you notice right here, this is the way you type in a fraction. You don't need to memorize that. What you could do is like right here where I typed in 4/3. If I copy that, so I just hit Control-C. I'm just going to do it right here so you can see. If I paste it in there, whoops, it automatically comes up with the coding. The only thing that you have to do additionally for it to show up as math type is the tick mark, is the key that's above the tab key on your keyboard. If I do a tick mark and a tick mark, now this is going to actually pop up as a fraction. So again, you don't have to memorize this coding. You can just go to any Desmos calculator, type in 4/3 and copy and paste it over. Again, there's a time when the cell is blank. So when the cell 1, 2 is blank, I'm going to say you have not entered anything. Otherwise, your calculations are incorrect. Try again. So same sort of thing working with the next two cells. So I have cell content, a message that will be given for the second problem. Again, you can't just type in a square root for your answer. I have to know what the square root of 10 is equal to, and the square root of 10 was, what was it, like 3.16 something. So when they type in the square root of 10, I want them to be given a message that they were. So again, I gave them a range when A2 is greater than 3.1 and A2 is less than 3.2. So anything within that range would be an acceptable answer. One thing to be very careful of, and I've made this mistake so many times, is make sure you're paying attention to the way you're defining things here. Sometimes I'll just be a little bit mindless when I'm working on something and I'll accidentally say A1 here and then A2 here, but then it doesn't work out because I need to make sure I've defined this row as A2. So you just have to keep up with your variables and make sure you're putting everything in the right spot. Again, I have a message that can come up because I know what they did wrong, and there are multiple reasons they could have got something wrong here. So like on this one, when A2 equals 10, you multiplied the radicans, but you lost a square root along the way. So in this case, I could just say when A2 equaled something because 10 might be something a kid will enter in there. I also have a time when the cell is blank. I also have otherwise. Then in the third cell, same thing. I'm giving a message. And again, very important for what we're doing right now, there's no way to check for a simplified fraction. So when I'm putting in the coding, I'm saying, since the answer was 2/3, when their answer is between 0.6 and 0.7, they got it right. They have all these other scenarios that I know what they did wrong. There's a time where they haven't entered anything. And then there's other things that I just don't know what they did, but they did something wrong. Are there any questions about that? Because I know that was a lot.
Is there a reason you used A1, A2, A3 versus just like A, B, C or something like that?
Nope. There's no reason. The only reason I do it that way is because how I learned to do it, it was originally I looked at an activity that someone created. I looked at what was happening in the coding, and that was the way that person did all of that. And so that's the way I learned, so that's the way I do it. The only thing that matters is, again, it's a variable, so each one is different.
Okay.
Any other questions? Okay, so there's an extra piece at the bottom that has nothing to do with feedback and has everything to do with the dashboard. If this is something where you're giving to students, and let's say you have multiple slides going on, you would have to look at every single slide, every single student's responses to know if they were correct. This is a situation where Desmos is not on the dashboard going to give you an X because we haven't actually told it what's correct and what's not correct. We've just said, we've given a way to get feedback so students know if they're correct, but as the teacher, right now you have no idea except for to scroll through all, 25 to 30 of your kids. So that's what this extra piece of code down here is for. This is so you can get a check mark pop up on the dashboard. So like, for example, if I go to my dashboard, I have a bunch of checks on these because I've told Desmos what's correct. So I can easily see, okay, you guys all got this correct, we're good. And then if you didn't get it correct, there would be an X there. So I know what kids are doing without actually having to click on this, look at the table, go to the next person, look at the table. So I want to make my life a little bit easier. So the way I did that is I have to give a correctness checker for Desmos. So the way I do that, the code for that is just to say correct with a colon. I have 3 things that have to be correct. This came from what happened in row 1, and this is what happened in row 2, and this is what happened in row 3. So this is basically telling Desmos if a kid does all 3 of these things correct, you get a check mark. If they get any one of these wrong, an X is going to come up on the dashboard. So now that I'm talking about that, let me show you what I did on the previous one since it's a little bit simpler because there was only one answer. So on this one, if I want to do the correctness, there was only one correct answer, and it was correct when A equals 7. So as long as a kid entered 7, I would get a check mark on the dashboard and I would get an X if they didn't enter that. If you have more questions about that piece also, 2 weeks ago, Javier's entire session was on correctness checkers. So if you haven't looked at that recording, I would say go back and look at it because there's a lot of things that he explains kind of the ins and outs of the correctness checker. All right, so then on the last one. All right, so were there any things you guys noticed about this one?
If you forgot to add all the dogs together, it told you to go back and read the problem carefully.
So was that was just like a random answer? Oh no, that one just said you're not correct.
If you said 4, so if you answered like how many dogs Annika had, it told you that you forgot to go back and like add all 3 persons. Yeah.
Yeah, so on this one, a kid might say, oh, I've got 2, plus I've got 3 more, I've got 1 less, 2 plus 3 is 5 minus 1. Yep, so right. 4 in, I got a specific message for that.
It also had the dogs.
Yeah, so I also put dogs in here. Does anyone else have anything that they noticed? All right, so let me show you how I did that one. So this one, there's an extra component that you don't see right away. So like, for example, with the tables, I have a note in a table, and that was the same thing that you saw here. There was a note in a table. All right, but when we did this one, there's a note, there's a place for them to enter an answer, and there's nothing down here until they submit. Once they submit, then this new thing popped up. All right, so the way that looks on this slide is there's a note with the directions, there's math input where students are entering their answer, but then there's an additional note because this information only appeared once students submitted. So on this one, you said that you saw dogs at the end. Well, that's a suffix because it's coming at the end. So I just said suffix, colon, and then with quotation marks, dogs. So this is saying what I want to have at the end of the cell. So if I type cats here, it wouldn't make any sense, but if I started typing, it would say cats. So you can put any suffix that you want on there, or you can completely leave a blank. You don't have to do that if you don't want to. That was just something that I thought would be a fun thing to do. Also, I noticed that when I look at my summary, it's coming up as a dot because I did not put a correctness checker on this one. So I'm going to go ahead and do that real quick. So I'm going to say correct when, and it's within this component. So I'm just going to say this dot, and the functionality of this is LaTeX, because this is a math input, and LaTeX is the terminology they use to represent math type. So I'm going to say equals, and since it's LaTeX, just like I showed you with the fraction, I'm going to do a backtick. I think the right answer was 11, and another backtick. So now, if a student types in 11, I'm going to get a check on my dashboard. Now the message that appears is this note is only going to appear once a student submits it. So like when I preview it, automatically there's a submit button. So when I type something in, it doesn't give me a message until I hit submit, because I want them to hit submit before things start appearing. If you don't say that it has to be submitted, a message will appear as they're typing, and it won't let them finish their thought. It'll just start telling them what's happening. So the coding on this one is I had to do a note. And so as you can see, there's nothing written within the note. It's all in the computation layer. So since this is a note, what I'm doing is I'm giving them a message. And again, I want this note to be seen when students have submitted their answer, and then based on what their answer is. Since this is a note, I'm giving them content because it's just feedback that I want them to read. So I have two things that I have to say. I have to say, oh, and also the reason that's there is because I labeled this math input. My label is dogs. So to refer to this input box, I have to use the word dogs. So when dogs dot submitted, and just as a heads up down here, I'll just start typing in what happens. When I start typing this in, you don't have to memorize any of this stuff. Number one, because you can just copy and paste these pages and change the CL that's in it for your liking. Or if you want to get to a point where you're doing it by yourself, when I say when dogs automatically appears, and I just hit enter because I have a component labeled dogs. And then I say dot, these are all of the different things I could do. So once it has been submitted. So when that component has been submitted, and dogs.latex equals 11, and again with the backticks because it's a numerical value and it's using LaTeX, you've submitted it, you've gotten it right, so I'm going to say great job. When you've submitted it and your answer was 4, this is the wrong thing that you did. When this input has been submitted and your answer was 6, this is the thing you did wrong. When your input was submitted, and so on this one, I put the coding for not, so when you did not get any of this stuff, you are not correct, try again. Any other situation, I don't want to give you a message. So dogs.submitted, this piece just came from, you submitted your answer, you did not get 11, or you did not get 4, or you did not get 6, you got some other random answer that I'm not aware of. And then this little note, anytime you're working within notes and you have a bunch of when statements, again, you have to end with otherwise. Even if you have nothing to say, you just put quotation marks and it's going to be completely blank. All right, are there questions on this slide?
And you did something on this one so it showed up as correct on the dashboard as well. That was in the math answer box coding, is that right?
Yes, because this is where they're putting their answer. So when I go in here, the correct answer is when this LaTeX equals 11. So when they got 11, now a check mark is going to appear on my dashboard.
Okay, so that prompt of correct is what sort of controls the dashboard.
Yes.
Okay. That's awesome.
Mm-hmm. Very helpful when you have 30 kids in a class and you need a very quick check to see how everyone's doing.
Yeah, that's extremely helpful.
Yes. All right, are there any other questions just in general about any of the 3 things now that we've kind of gone through all 3 of those different types of giving feedback? right. Well, if that's the case, let me stop this recording.